Let's take a look at the solutions to the questions behind me, starting with the top question, where we sketch a right triangle with acute angle theta such that the tangent of theta is 24/7, and after which we want to find the sine and cosine evaluated at theta. So we need to first recall the definition of tangent of theta, where the tangent of theta is equal to the opposite over the adjacent side of a right triangle. And by information from our problem, we know that should be equal to 24/7. Now, what will we do to find or to construct a right triangle meeting these requirements? Well, the easiest way here is just to say, well, note then that we could let our opposite side equal 24, our adjacent side equal 7. And we could meet this requirement then that the ratio of the opposite over the adjacent is 24/7. So we construct that triangle. Why don't we do that here? So we'll have some right angle, and we'll have our adjacent side be shorter. So let's let this be theta. This will be our adjacent side. Our opposite side will be 24. And using this triangle, we can compute the sine or the cosine of theta. Why don't we do that here, and then we'll make a comment about our choice for the opposite side and the adjacent side. So we can say that the sine of theta we know would be defined as the opposite side over the hypotenuse. Now, to find the hypotenuse of this right triangle, we would use the Pythagorean theorem. And so to find this side x, let's call it, it's going to turn out to equal 25. What we would do is we would just look at using the Pythagorean theorem, x squared equals 7 squared plus 24 squared. And solving that, we will find that x is equal to 25. I'll save that work for you. Let's continue working. So the sine of theta is equal to then the opposite side, which is 24, divided by our hypotenuse, which is 25. So we find our value for the sine of theta being 24/25. Similarly, we could find the cosine of theta being the adjacent side over the hypotenuse, or 7/25. So let's go ahead and box our answers there. And then make a comment about our choice for the opposite and the adjacent side. Now it turns out that we could have chose a number of different combinations of an opposite and an adjacent side. In particular, from our definition here, or from this part here, we know that the ratio of the opposite side and the adjacent side must equal 24/7. Well, see, that just says that the opposite side needs to be 24/7 times the adjacent side. And that would work for really any adjacent side length we chose that's reasonable or within the domain of possibility, which would be any positive side length. So really we could have constructed any triangle meeting these requirements where A is some positive number and the opposite side is just 24/7 times that positive number. Again, we chose maybe the easiest option there, just a direct relation between the numerators and denominators of that ratio. Let's go ahead and look at the second example now, where we consider the diagram below to find the length of the shadow S. So the diagram is pretty well informed here. We're looking at this S length we'd like to find. We know the height of our tree is 10√3 feet, and we know the angle that from horizontal to the shadow, to the height of the shadow, is 30 degrees. So what do we need to do? Well, we need to look at these quantities. We need to see how they're related and somehow use a trigonometric function to use that relation to evaluate S. So see here that we could identify some right triangle. We could see this right triangle with included angle 30 degrees with legs of length S and 10√3 as drawn here. Well, how will we compute then our side length S? We'll note that we're comparing an included angle, its adjacent side, and its opposite side. And by use of the tangent function, we could find a relation between those quantities, noting that the tangent of theta is our opposite side over our adjacent side. We can say that the tangent of 30 degrees is equal to our opposite side, 10√3, over our adjacent side S. by rearranging, we could find that S is equal to 10 root 3 times the tangent of theta. Tangent of 30 degrees, excuse me. We can note that the tangent of 30 degrees is just the ratio of 1/2 and root 3 over 2, so we'll have 1 over root 3, and so the shadow length must be 10. Note that the unit we're working with here is feet. We'll go ahead and put a box around that solution, and we are done.